This
demo session.
conference will now be recorded.
This is the demo session for VLSI front-end domain. So as part of this session, we'll be understanding the various aspects of the VLSI front-end domain. So before we get into the front-end domain, as you are aware, VLSI domain has two aspects. One is the front-end domain, one is the back-end domain. Uh, so front-end domain consists of various aspects like RTL design, RTL integration, and RTL verification, and the DFT that is done at the RTL level. So now let's try to understand what exactly is this front-end domain stages. So when we say RTL design, what exactly it refers to? To understand, let's take a one simple example of C program. Let's say we take a bubble sort, one of the sorting algorithms. The bubble sort can be implemented using C program. C program can be used to implement the bubble sort. For example, I mean, this work will be done by a software developer. The the C and this C program needs to be tested. So that will be done by a software tester. Role of a developer is to develop the program, and the role of a tester is to test that program. Same way in VLSI domain, the front end domain, to manufacture a chip, we need to develop a Verilog code. That will be that Verilog code will work as a mobile phone. So that work of developing the Verilog code is done by the RTL design engineer. So let's say one team will develop CPU subsystem, another team develops GPU subsystem, another team develops modem subsystem. That all what goes inside a mobile phone. So the team which develops these blocks are called as RTL design team. The team which integrates all these subsystems into one single system on chip is called as RTL integration team. So just to summarize, now we are talking about the front end domain. Front end domain majorly has three aspects. One is RTL design, one is RTL integration, one is functional verification. So the design team is responsible for implementing the Verilog code. The integration team is responsible for integrating all the subsystems into one single chip. The verification team is responsible for verifying the functionality of this Verilog code.
This conference will now be recorded.
The person, there will be another team, RTL integration team, integrates all these subsystems into an SoC. Did you understood? Like one team has developed CPU subsystem. They will they won't give the chip. They will give the which code they will give Verilog code. Which language they have used? Verilog. Like we have C language, there is a Verilog language. In that they will develop the CPU subsystem behavior. What they will develop? ALU, fetching block, decoding block, various things, you know, right? In a processor, everything is there. They will develop all that Verilog code. There will be another team who will develop GPU subsystem. There will be one another team called as integration team. What do? They take everything from the all the teams, they integrate, put together one chip. That is called as integration team. There will be a third team, verification team. Tell me, what do you understand from verification team? Their role is similar to. So what are they going to do? Whatever Verilog code that has been developed, whatever has been integrated, is it working fine? Are there any mistakes? What will happen if there is a mistake and it is not found? What will happen if my Verilog code has a mistake and that mistake is not found? What will happen? That will go into the chip. Then will it work if there is a mistake in the mobile phone? Then what will happen? Let's say I spend some 20,000 for example. What will happen? Waste, right? So I will again return to them. So who is losing? I am losing or company is losing? Company is losing, right? So it's a big problem. So what they do is they have a dedicated team called as RTL verification. This RTL verification is also called as functional verification. Both are same. Sometimes people call ASIC verification, RTL verification, functional verification, ASIC verification. All are referring to the same work. So what is their work? Find any bugs. Bugs means issues in the Verilog RTL code. Now what is RTL means? Register transfer level. Means it's one style of developing a code. It's one style of developing a code. In Verilog, there are multiple styles in which Verilog code can be developed. One style of developing Verilog code is register transfer level. So these are the things that are majorly constitutes in the front end domain. Now do you understand what is meant by RTL design, what is meant by RTL integration? The person who develops the blocks is called as design engineer. Person who integrates them is called as integration engineer. Okay. What is their role? They get one Verilog code, another Verilog code. They connect those Verilog codes. How do they connect? We'll discuss as we go forward. Means I don't want to teach entire thing in one demo session. We'll cover everything as we go forward. The person who verifies this entire thing is called as functional verification engineer. Today we also have demo session for DFT, designed for testability. If some of you have enrolled for DFT and attending demo session, we will have one more demo session today or tomorrow. Our admin will inform you the exact schedule. The demo session is from 9:30 to 12:30 or 1 it will go. DFT demo session, our admin will inform you the time. Now let's get into the technical part of our demo session. First, let us start off with understanding what is an electronic system. It is to help you get the top level overview. My understanding is that during your BTech, no one probably would have introduced you to that. Our BTech curriculum is not structured in that manner. It's mostly uh, not framed for the current requirements. Ideally, your learning should start with understanding electronic system, then they should go down. Rather, we are starting bottom. First, we are learning CMOS, BJT. So it's not properly structured. So we want to start off with giving the top level structure of the electronic system. Then what is what? So first, let's start with the electronic system. So first, let's understand what all things goes into an electronic system. So let's take an example of a mobile phone. So tell me what all things, if I show you mobile phone, what all things goes into a mobile phone? What you see is the hardware. First thing you see is what? Hardware. Inside that hardware, what else is going on? My mobile is there, just a hardware without what is the operating system will have? Mostly Android, right? Or if it is OnePlus or some, I mean, if someone can have their own custom Oxygen OS, right? Let's assume Android. Without OS, will it work? No. Okay. Let's assume I have only the mobile phone and I have the operating system. Will it work? What else do we require? Sorry. Processor is part of the hardware. See, when I say hardware, everything you can see physically is a hardware. Processor is a hardware. GPU subsystem is a hardware. Everything is a hardware. Someone is telling software. Operating system is the software. So what else do we require? Sorry. Power consumption. Power is a battery, right? Battery is also hardware. Everything I am telling you, right? When you touch the mobile, anything you can feel physically, chip you can feel, right? That is a hardware. Let's call it like that. Operating system is the one which is running. Do you think is there anything else present in the mobile phone? there is something called as firmware.
Camera.
Driver. No, camera can I feel? So tell me, what is it? Hardware, right? I'm telling you, my definition is simple. Anything that I can feel with my hand is a hardware. Operating system, can I feel? No, right? It's a piece of code, so I cannot feel it. So majorly, what else is there other than that? Applications are there. WhatsApp is there. So can I count WhatsApp as part of my operating system? No. So if you see, there are majorly those attending online, please be in mute. When you have a question, you can unmute. Again, I'm requesting those attending online, please be in mute. Sanjeevani, please be in mute. So electronic system consists of four components. One is the hardware. As I said, hardware is anything that you can feel. Camera is a hardware for me. CPU is a hardware. My this frame is a hardware. Everything is a hardware. Anything I can feel with hand. Then I have something called as drivers. We can call drivers as the firmware. Then you have what? Operating system. Then you have applications. Let us now try to understand what is the significance of these things. I told you this, what you see here is the hardware part. I mean, it could be camera, flash, antenna, satellite, a DMB tuner, camera, whatever, different things. Everything I can feel physically. I can touch and feel them. So they are all part of the hardware. What you are seeing is a hardware. A electronic device. In this example, the mobile phone will not work if I just take a hardware. If you don't use drivers, it won't work. If you don't use operating system, it won't work. Without apps, you can work, but apps are useful, right? We are using mobile phone because apps brings more convenience. What all things goes into mobile phone? As I said, hardware. It is everything that you can feel. Chips, processors, screen, camera, sensors, audio, everything is a hardware. Then you have firmware, which is also called as drivers, operating system, Android, iOS. Then you have got different apps. Apps is the applications. What is the first layer in the mobile? Bottommost layer? Hardware. Processors, camera, sensor. Who develops the hardware? What is that person is called as? Hardware engineer, right? Or in our case, we can specifically call as VLSI engineer, firmware or drivers. What I can call him as? Firmware engineer, also called as embedded system engineer. Either you call firmware engineer, embedded system. This is where I wanted you to have a clarity about what is VLSI, what is embedded system. See, there is a confusion, right? Because no one would have probably taught you, so you don't know what exactly is VLSI, what is embedded system. The person who develops the hardware is called as VLSI engineer. His responsibility is only to develop the hardware. Embedded system engineer role is what? To develop the firmware. He develops the firmware. Operating system. Who is that person? Software engineer. Applications like GPay, Maps, WhatsApp, everything, right? Who develops it? Again, it's a software engineer, or you can call app developers. You cannot think of a electronic system without hardware. See, can I use mobile phone without having this hardware? No. Again, can I use this mobile phone without having operating system? Same thing, right? If anything misses, the phone won't work the way it should. Let's take a analogy to understand this electronic system. So we will take an example of a bus with passengers. In this example, Bus is like the hardware. Bus is like the hardware. Driver is like the firmware. Okay, that's why we are calling it him as driver actually. Why? What is the role of a driver? He controls the hardware. Driver controls the hardware. Understand the statement? In our case, what is the hardware in bus example? Bus. He's the person who makes all the control, right? Stopping, accelerating, taking turn, everything. Same way in real life also, in the mobile phone also, there is something called as drivers, which controls everything in my mobile phone. For example, I want to take a photo through the camera. Operating system tells to camera driver. There will be something called as camera driver, or you can call multimedia subsystem driver. Some driver will be there, which will go and tell to the camera that now you take a photo. Let's say I want to connect through USB to data transfer. So what is coming into picture there? USB. There will be an USB driver. What driver will be there? USB driver. My operating system tells to whom? Camera driver, sorry, not camera, USB driver, to tell USB to start the transfer. Understood? For anything to work in the mobile phone, drivers are required. Then driver will control the hardware. In bus example, how many drivers you have? One driver. But in mobile phone, there are multiple hardwares are there, multiple blocks are there. USB, PCI Express, camera, GPU, different components are there. To control each of them, we need one more driver. One driver cannot control everything. One driver cannot control USB, cannot control PCI Express, cannot control camera, everything. There will be a driver required for camera. Because what is the role of a driver? See, when you click here to take a photo, the communication goes to operating system. That user wants to take a photo. Then it starts the driver. There is a driver inside. Tell me, driver is a physical element or is it a code? It's a code. Driver is a code. More specifically, driver is a assembly language instructions. What is driver? Assembly language instruction. Tell me, what is assembly language? Something that is coded specific to a processor instruction set. Like you have x86. What is the other architectures you are aware? ARM, ARM architecture. So you can develop those codes. What are the codes I'm talking about? Add instruction, subtract instruction, multiply, branch. So that my driver actually has that code, which will control the hardware. So what will happen when I'm clicking a photo? The photo that click goes to operating system. Operating system tells to the camera driver that user wants to take a photo. Then camera driver goes and controls the camera to take the photo. This all involved. It happens so fast that we don't notice it. Whatever clock running in the camera is very fast actually. Hence, we don't notice all these things happening. Have you understood the role of a driver? What is the role of a conductor? Operating system. He works as an operating system. Passengers, applications. As a passenger, I want bus to stop. What do I do? I am the application. Will I directly go and control the bus? No, right? I won't apply the brake myself. What will I do? I talk to whom? I won't even tell to driver. I will tell to whom? General procedure is what? Conductor, right? So conductor will tell to, again conductor will control the bus. No, he tells to driver. Then driver makes all the decision. There are times where you will see only one driver is only there, right? No conductor, he only takes the tickets. So that will be a system where you don't have, everything is integrated into one thing. RTOS people, I mean, see, there's a different ways in which hardware can be developed. In one methodology you can merge everything into one single thing. Okay, I told you, right, the process. The same happens in our electronic systems also. Anytime you start the application, first it communicates with operating system. Operating system communicates with driver. Driver communicates with hardware. Let us now understand what is a driver. A mobile phone has multiple drivers. Tell me why multiple drivers are required. Driver required for controlling each part of the hardware. Camera driver required for controlling camera behavior. For example, I have an audio, right? I can increase the audio and I can decrease the audio, right? The volume level I can increase. Again, that there also some driver will be involved. To do anything, right? To do anything, there will be a driver will be required. Let's now understand what is exactly a driver. What goes into a driver? What goes into a driver? Let's understand. Tell me again, when I say driver, is it a code or is it a hardware? It's a code. Driver is a code. More specifically, this is assembly language instructions. What will be the assembly language? Depends upon which processor. For example, let's say I'm using WhatsApp on my mobile phone. Assume I'm using WhatsApp on laptop also. Is it possible to use WhatsApp on laptop? It is possible, right? My mobile phone is based on which architecture? ARM architecture. It has got a Snapdragon processor. My mobile phone has what? Snapdragon. Snapdragon is from which company? Qualcomm. Qualcomm company releases a processor called as Snapdragon. So my mobile phone is developed using that architecture, which is based on ARM architecture. My laptop is based on Intel architecture, which is x86 architecture. My laptop is based on x86 architecture. You see, in my mobile phone also WhatsApp is there. My laptop also WhatsApp is there. But the instructions that I have in my mobile phone is different from this one because x86 architecture is different, ARM architecture is different. So they would have developed two different codes, one specific to mobile phone, one specific to laptop. Anyway, let's not go to that level, I mean, that aspect. For now, let's understand that driver is nothing but a code, which is nothing but assembly language instructions. So when you start the any application, any that particular component, you want to do something using the camera, you want to do something using the camera. So then what will happen? Processor starts running these instructions. Where are these instructions are present? The drivers are present in DDR memory. You know, in your mobile phone, DDR will be there. System memory, there will be either 8 GB 12 GB or 16 GB. You can have various things, right? You would also know that based on the amount of memory you have, DDR, your performance will be better. So then processor starts running these instructions. Can you tell me why DDR size, let's say if I increase from 4 GB to 8 GB, why my system performance improves? Tell me. How does the performance improve? So when I increase the DDR size from 4 GB to 8 GB, why does my system performance improve? Tell me. So let's understand a little bit about what is DDR, what is storage. Anytime user starts the system means what? It's a laptop or mobile phone, either laptop or mobile phone. All the applications and data is present in storage memory. What is storage memory in my laptop? Tell me, what memory is storage in my laptop? SSD, either SSD or HDD. The DDR in a 4 GB RAM or 8 GB RAM will not have anything but power up time. When I just power on, nothing is there in DDR. Then what will happen is, as you start the application, something called as boot process will start. You know, you would have heard term called as my system is booting. Even in your laptop, it's booting. What do you mean by booting? It starts some essential process. Then finally, what will happen is OS kernel. Kernel is like a core of the OS, core functionality of the OS gets loaded from storage to DDR. Boot will happen followed by OS kernel. Where is OS kernel present? Originally present in storage. See, where do you install your operating system? Do you install in SSD or do you install in DDR? SSD. You don't do any installation in the DDR memory. Why? Because DDR is a volatile memory. Volatile means once you power off, it loses the charge. Let's say once I switch off my laptop, shut down my laptop, entire information in the DDR is lost. Everything is lost. That is where we keep all the information in the storage. Now when you boot up and then when you load the OS kernel, what will happen is this happened. Boot happened. Inside your storage, you know what drive is there? C drive is there. Inside the C drive, OS kernel is there. That specific data is moved from SSD to what is moving? OS kernel is moving. OS kernel is the core thing which will start working as a OS functionality. Then when I invoke an application, let's say now what will I do? So this has finished. This has finished. Means my system is booted up completely. Now when I go to my laptop, it has booted up. Now what I did, I went right click, send to pen drive. Let's see. What did I do? right click and send to pen drive. Some drive connected, I send. This is where the USB driver will come into picture. Why USB driver will come into picture? Because I want to send the data to pen drive. Pen drive is what? Pen drive is connected through what? USB. So what driver will come into picture now? USB drivers will come into picture. So what does USB drivers will do? USB driver is nothing but assembly language instructions. These instructions are loaded into specific memory. These instructions are loaded into specific memory. Then what will happen is the processor will start reading those instructions, that is called as fetch, decodes the instructions, execute the instruction. If you have studied any processor instruction architecture, you would have heard terms fetch, decode, execute. What is it fetching? It is fetching some hexadecimal number. What is my processor is fetching? See, fetching means what? Getting it, right? So from here, some instructions it is getting. Let's assume it gets a number called as 32 hexadecimal 12001357. Randomly I have written some number, okay, randomly 12001357. My processor decodes this instruction. It understands that. For example, it may understand it as add R1 R2 comma R3. Tell me what does this operation will do? Add R1 R2 R3. What do you think this does? It adds register 2 with the contents of register 3 and store entire thing into what? To R1. You may be thinking, I am running a USB driver. Where is this add instruction will come into picture? If you open the USB application at very low level, this is the codes running actually. These kind of codes are also only running. Add, subtract, jump, branch, multiply. Different instructions are what is present in my USB driver. Then what will happen is it fetches those instructions, decodes, execute. As part of that flow, my processor will go and do some register program in the USB controller. This register programming is happening because of these instructions. It's like I'm giving you some instructions. You are the processor. I have the instruction code. My code is like hexadecimal numbers. My code is like what? Hexadecimal numbers, something like this actually. Something like this. 32 hexadecimal 39029320320 3209329. Some codes are there. You know, you have heard of term called as program counter in processor. It will start getting these instructions. Who will get these instructions? Processor. From this, it understands that I have to do a addition. I have to write into memory location. I have to get some value from the memory location. That kind of things it will understand. Who will understand? Processor. As part of that, understand, as part of that, it will go and program the registers that are present inside the controller. Because you are doing some programming there, it starts doing the communication. Let's again repeat. Assume this person is USB controller. This person is processor. If he doesn't tell him anything, he will not do any work. The USB controller Person will just keep sitting. He will not do any work unless someone tells him to do. Who is the person who can control him? Only processor can control him. So processor is the person who can control this person. Processor also doesn't do anything by itself. If I just keep my mobile phone for 10 days, will it do anything of itself? It has a processor, right? My mobile phone has a processor. Will it do anything by itself? No. Why? Processor also needs some inputs. What are those inputs? Those are called as drivers. Drivers are what? Assembly code. Why assembly code? He understands, this person understands only one language. He doesn't understand English. Who is that person whom I circled? Processor. Processor doesn't understand Verilog, does not understand C language. He only understands his language, that is called as machine language. What is the language he understands? Machine language. Machine language is also called as what? Assembly language code. What is the role of an embedded system engineer? Is to develop those codes. What is the role of an embedded system engineer? He develops the codes who will finally control the processor. In turn, whom he is controlling? By controlling him, whom I am controlling? Let's say I am the driver. I am through processor, I am controlling him. Through the processor, I am controlling. Essentially, whom I am controlling? Finally, USB controller only, right? I am taking the help of processor to control the USB controller behavior. I am telling to processor that you go and tell USB controller to start doing the transfers, start reading the data. All that will happen because of processor getting the instructions. Now the next question. Drivers also don't do anything by itself many times. Someone has to tell them. Like, does my laptop automatically start doing the transfers? Who is telling him? I am telling the user. Application at application level or OS level, I went here, I right click and say send data to this one. Then what happened at operating system level? See, this is operating system, right? At operating system level, I initiated a transfer. Then it tells to the processor, now you run this driver. Means it changes the program counter. We will change what? Program counter to start running USB driver application. Then this entire process will happen. You got the basic idea, right? In this case, where is DDR coming into picture? Let's understand. This is actually DDR memory. Let's say my storage is connected here. What is the storage? SSD. When I started the laptop, this is completely empty. Empty. Why it is empty? The DDR memory works in such a way that only if power is there, it will hold the data. If there is no power, no data. If there is no power, no data. What about SSD? If I remove the power, will it hold the data? Yes, it holds the data. Even if you don't give the power, it stores the data. So what happens when you power up your laptop? The applications that are present here. Let's say I'm opening PowerPoint. Okay. I'm opening GoToMeeting. I'm open GVim. These are all the applications actually. Those data is moved to DDR. Those applications are moved from storage to the DDR. To do that movement, there is a block called as DMA controller, direct memory access. So this all is done by the booting process, OS kernel, everything. This is to give you a top level picture. So let's revise everything. What did you do first? You started your laptop. Fine. First, what happens very first thing? There is something in my laptop called as boot ROM. What is there? You would have heard boot ROM, right? That has got the very first thing that my processor has to run. Once it is done, something called as OS kernel, operating system kernel. Kernel means core of the OS. Okay, central part of the OS gets loaded. Once it is loaded, as a user, I go and let's say, for example, I was talking about playing a thing. Let's say I open this PPT or I start playing some music. What will happen? Playing music, will it have anything to do with USB driver? No. Playing a music has to do with the audio block, right? My laptop will have a audio subsystem. Which drivers will be called now? Audio drivers. Understand? My operating system will call the audio drivers. So what is the role of a operating system? It is like a group leader under whom multiple people are working. What is operating system? It's like a group leader. He has audio drivers, he has USB drivers, he has SD card drivers, camera drivers. He has multiple people working under him. When I go and tell him that you do audio work, he will call the audio driver and ask him to do the work. And at the hardware, who will do that work? Processor will do that work. So this is a brief about how the things work. As I said, initially all drivers are present where? Storage, and these will move to the DDR. What is the advantage of bigger DDR? More is the size of DDR, more applications you can move, right? If the DDR size is bigger, from storage you can move more applications. See, right now whatever I have loaded here, you see down, you see everything Chrome, go to meet, PowerPoint, the note text editor, all this information is actually loaded into my DDR. If my DDR is bigger, I can load more applications and my system will be more faster. System will be fast. See, then OS will inform processor to start running instructions of a particular driver. Processor gets the instructions from the DDR. It is called as what? Fetch. What does it get? Hexadecimal code. That is called as what? Opcode. That the hexadecimal number processor is reading from the application is called as what? Opcode. Operating code. Operation code. Operation code. Op code. Then what will happen? Processor decodes the meaning of the opcode. I mean, it understands what is mean by this. It is not a random number, okay? It's like they have a meaning. What is the meaning? 123 means some data. 748 means something. There is a proper decoding is there. Based on that, processor knows that okay, I have to do addition or I have to do multiplication. Then line number 57 is what? Processor executes the assembly instruction. As part of that, it will go and program what? USB controller. It's like he will go and control the USB controller behavior. So then USB controller will start doing the communication with the USB pen drive. Let's repeat. USB controller by itself will not do anything. Who has to tell him? Processor. Again, processor by itself will not do anything. Processor by itself will not do anything. Who has to tell him? Drivers. To call the drivers, whose work is it? Operating system. Again, operating system, who has to control? User. As a user, when I am using my laptop, I will control which application I want to use now. Even when I am running WhatsApp in my mobile phone, what is happening? WhatsApp application is a set of assembly instructions. They are getting called, and all that is happening. This is a brief about how the drivers work. I think I have explained all this. This is all fine. Do you want me to explain anything further? Let's do some question and answers quickly. What is a volatile memory? What is volatile memory? Type of memory which loses information once power is removed. What is an example of a volatile memory? DDR. Even cache is an example of a cache. You would have heard L1 cache, L2 cache. These are all volatile memories. What is a non-volatile memory? Tell me. What is non? What is the definition? Type of memory which does not lose information once power is removed. What is an example? SSD, HDD, boot, ROM. ROM is also example, right? And any kind of flash memory, any kind of flash. In fact, what goes inside SSD is a flash memory only. USB pen drive is there, right? Does it lose charge once you remove the power? Does it lose information? No. So is it volatile or non-volatile? Non-volatile. Because inside pen drive, flash memory is there. Flash stores the charge in between transistor. It traps the charge. What does flash do? In between the transistor oxide and metal, right? Between the substrate and oxide, it traps the charges, either positive charge or negative charge, and it insulates it. It's like right, a thermo flask, tea can be put into. What will happen after one day also if everything, the thermal flask is good? Let's say this is thermal flask. If you keep the tea inside thermal flask, after one day also it will be hot. Why? The thermal flask won't let the heat go outside the flask, right? Same way, here how many thermal flasks you have? One. In my flash there will be crores and crores of such transistors are there. Each transistor is storing one value. That trapping won't let the charge move out. It will create a shield around it. Okay, insulator shield. It won't let it move, so that charge will hold. Even if you remove the power, that positiveness or negative charge will hold. That is why these are non-volatile. How many layers are there in electronic system? 4 layers. What are those 4 layers? What is at the top level? Application, right? Below application, operating system. Below operating system, driver. Below driver, hardware. You know that, right? What is the role of a VLS engineer? His responsibility is to develop the hardware. Responsibility is to develop. What is the role of a embedded system engineer? Develop drivers or firmware. His role is to develop. You go to example of a bus only. Let's take bus analogy. The driver, the bus driver, does he manufacture the bus anytime? Is he concerned about anything at all? Does he even manufacture a seat? No. His role is only to what? Control the bus. You see, somewhere else there is a bus manufacturing plant is there. What is their role? Is to manufacture a bus in such a way that it is easy for the driver. See, they should give controls in such a way that it should be easy for me to drive the bus. Understood, right? If I keep the brake somewhere, accelerate somewhere, will it work? No. So they will develop the bus in such a way that his hardware will be developed in such a way that my embedded system person should be easily able to control the hardware. It should be easy for him to control the hardware behavior. So that's where both people are involved. I should know when I'm developing my hardware as a VLSI engineer, I should understand what is the requirements of an embedded system engineer and develop my hardware accordingly. Next, let's do some question and answers further. What is inside a driver? Finally, what is finally present inside a driver? It is assembly language. At very basic level, my PowerPoint application, my GVIM, everything you are talking about, everything at very basic level, these are all assembly language instructions. But the embedded system engineer, who is responsible for developing drivers? Embedded systems engineer, right? Which language he uses to develop the drivers? Assembly, right? But what he does is he won't develop using assembly language. He will develop using C language. Uses C language to develop drivers. You may say it is confusing, right? What is confusing? Tell me. I am telling that driver is assembly language instructions. Then very next time I'm telling he will use C language. Tell me. There is something called as you would have heard compilers. If this code is given as an input to the compiler, it generates this code. If C language is given as input to the compiler, what that will generate? Assembly language. It is easy to develop a code using C language actually, because if I have to develop a code, simple example, take this for loop. Tell me what is it doing? Tell me what am I doing in line number 62 to 64? I have an array, integer array of size how much? 10. I am adding all those array numbers, storing into sum. Let me repeat. I'm going through a for loop. Index starting from where? 0. Going till where? 10. And I'm adding all the array elements and storing the result into what? Sum. The same thing if I have to do using assembly instructions. Using what? Assembly instructions. It will take a lot of effort. Let's briefly understand what might be involved. Li T0 load immediate value. Li means what? Load. Even if you don't understand everything, no problem. It is just to give you a feel of it. Okay, instead of T we have to use S because I have to store the value. It's 10. Why I use T? Because it is temporary. It keeps changing. I will keep changing. Will 10 keep changing? No. Hence I use term S. S means fixed. Store. It will store that value. It won't change. Then I have to write a loop for this loop, right? Add. Load immediate. T1 0. This is the sum. Finally, you are having sum, right? Sum is mapped to which one? T1. Why did I use T1? Because it keeps changing, right? Sum will keep changing. Add T1, T1 comma T0. Then add T0 comma T0 comma 1. Add I, it is immediate. Branch less than T0 comma S0 to loop. Then finally, once it is done, store word T1. So add immediate is T1. No, this is fine. T1 to the 0, some memory location X T2 or something. In summary, what I'm telling is this is more easy to understand. This is little difficult to understand. Okay. Uh, Actually speaking, I'm still not referring to the array. I have to refer to the array also. Finally, this code is not complete because I'm not referring to array anywhere. I'm just directly adding what? I'm not adding the array. I'm rather adding indexes, which is wrong. I have to first get the data from the memory and then use it. So this code is still not complete. Point I am trying to emphasize is from a developer perspective, is it easy to develop this one or is it easy to develop this one? First one. So the embedded system engineer develops in this manner, kind of. Then when I use a compiler, this code, if I give as an input, it will automatically generate this code. What is the role of a compiler? When I give this code as an input, the for loop as an input, what it generates as an output? Assembly code. So you are hidden from that. You don't have to bother about assembly code. Rather, in which language you develop the code? C language. This is why embedded system developer always uses what? Embedded C language. There is a category kind of coding style called as embedded C. Understood? Finally, when I say drivers and everything, it is actually this is what he is going to develop. But finally, when he compiles, it gets generated. These are the instructions which are actually running in my laptop. Anything I'm doing, even when I'm running GVim application, even when I'm running this GoToMeeting application, right? At every time, this is what is getting, these instructions are what is getting run. Next. Can be discussed. How processor controls the USB controller behavior. By programming the registers present in the USB controller. These are some of the questions. Let's. Does laptop has only one driver? Multiple driver. Why multiple drivers? One driver has only one specialization. Let's say I'm car driver. I can drive car. Can I go and drive a JCB? Can I drive a tractor? No, I can't do, because that requires a little different skill set. So if I have 5 vehicles which are of different types, I need 5 drivers for that. Same thing is the thing here. The laptop also requires multiple drivers to control each of those hardware elements. Finally, driver is a assembly code. Who developed that assembly code? Embedded system engineer. In which language did he develop? C language. Why he used C? Why not assembly? Because it is more easy to code. Simple for loop, if condition, else. It's more like English. If this happens, do this. In assembly, it's not like that. See, is that like that? It's difficult to understand what are we doing unless you have to sit for 10 minutes and understand. The same you can understand in half a minute. So what is used to convert embedded system, the C code to assembly code? That is called as what? Compile. If you are using ARM processor, it is called as ARM compiler. If I am using x86, it's called as what? x86 compiler. So depending upon what you are using, there will be a compiler for it. So this is, as a VLSI engineer, what do you need to know? As a VLSI engineer, you should be good with hardware. You should have very good understanding of how the hardware works and how to develop the hardware, in-depth understanding of the hardware process. You should also have understanding of how firmware interfaces with the hardware, how embedded system will control me. The basic understanding of how firmware controls the hardware. VLSI engineer don't need any understanding of operating system and application. Let's say I'm developing this mobile phone. I'm into a team who develops this mobile phone. I don't need to know which application will come. WhatsApp will come, how WhatsApp works. I don't need to bother. Got it, right? I only need to know how the hardware developed and how drivers will control me. That's all. Like a bus manufacturer doesn't bother who will come and sit. Will I go and sit or someone else will sit? He doesn't bother. He only bothers how to manufacture the bus and how my driver will control the bus. That's all, right? He won't even bother about conductor also. He's only concerned about next level. What is next level to the hardware? Drivers. That's all. So this is a brief about understanding of electronic system. Okay. We will go for a break. See, idea was to give you a top level picture. What is what, right? I want you to, at your free time, you can do this little bit of Google search. You will get lot of details. Okay. We will go for a break now. Then we'll talk more specifically about VLSI. Only about VLSI. Till the break, we were discussing about very generic topics. What is VLSI? What is embedded? How the system will start everything. So now, when you start learning VLSI, you will be able to make an idea of what is VLSI and what is hardware. Okay. So let's meet in 15 minutes. 11:15 we'll meet and continue further. Okay. Someone has asked a questions. All the questions we'll address after the break. Let's meet at 11:15.
This conference will now be recorded.
Now let's continue with the VLSI aspect. So let's continue with the understanding of VLSI design styles. Okay, first of all, what exactly is VLSI? It stands for very large scale integration. So what are we integrating? Transistors, right? Then what does it mean by very large scale? We are integrating billions of transistors. Since we are integrating billions, we are calling it as very large scale. Let's now understand two major styles of VLSI. There are two major styles of developing the VLSI chips. One is called as ASIC, one is called as FPGA. ASIC stands for application specific integrated circuits. In ASIC, the hardware is developed for specific application only. Example, mobile phone chip. That means if I am working on a ASIC project, so whatever chip that is being developed, it will only work as a mobile phone only. If my team is working on mobile phone chip using ASIC style, that will only work like a mobile phone. I cannot use it as a laptop. I cannot use it as something else. Whereas coming to FPGA, it stands for what? Field Programmable Gate Array. It's like gate array means what? This is a gate. This is a gate. What is gate? Logic gate, AND gate, OR gate, XOR gate, like that. You can program these things the way you want. That gates you can program the way you want. You can program one thing as OR gate. This you can program as AND gate. The way you want, you can program all of them. Then once you program, you get the required behavior. Same FPGA board can be programmed to behave like different applications, that is different electronic devices. That means same FPGA board can behave like a mobile phone, same board can be programmed to behave like a laptop chip. So that is called as FPGA. Which one looks better, ASIC or FPGA? FPGA going initially what? Same thing we are able to use as a mobile, same thing we are able to use as a laptop chip. Means in FPGA what happens? You have one board called as FPGA board. This board can act like a mobile phone. This board can act like a laptop chip also. Whereas in ASIC, only one thing. If you develop as a mobile phone, it's only mobile phone. You cannot use it for anything else. Though it looks like FPGA is better, industry prefers ASIC design flow due to low cost of manufacturing. Just to give you some numbers, FPGA may cost $50 per chip. Same chip, if you do with ASIC, it may cost you $15. Same functionality, if I develop with FPGA, it will cost me $50. ASIC will cost me only $15. So which one I will prefer as a company? ASIC. Why? Because when my chip cost is less, my final product cost also will be less. The next question is, if ASIC is cheaper, then why don't we do everything with ASIC only? You understand, right? If ASIC is cheaper, why not do everything with ASIC only? The answer is, for ASIC initial investment is high. To set up that flow, right? To set up the ASIC flow, the initial investment will be high. Once you have set up the flow, after that per chip manufacturing cost will be less. Let's understand these differences. This graph you see, the diagram explains you that. In ASIC, this y-axis is what? Cost. X-axis, number of units. How many units you want to manufacture? X-axis is the number of units you want to manufacture. Y-axis is the total cost. In when you are talking about 0 units, this point is what? 0 units. The initial cost of FPGA is this much only. Whereas for ASIC, initial cost is this much. The red line is what? ASIC initial cost. How much you have to minimum spend. In FPGA, it is lesser actually. Why it is less in FPGA? Because the board is readily available. You don't have to start from the scratch. You have a board in which you are already programming something. On the board only you are programming the required hardware behavior. Whereas in ASIC, you don't have anything. You start from the silicon level. Because of this initial investment, okay, uh, this will be higher. So the point is what? See, if you look at this point, let's say this number represents 2000 units. This point represents what? 2000. Now tell me, if I want to manufacture 1000 units, I know that I'm developing a chip. Throughout its lifetime, 1000 chips only will sell. What is that I'm developing? I'm developing one hardware. I want to sell that. I know that only 1000 will only sell. Will I go with FPGA or will I go with ASIC? Tell me. Which one is cheaper? See, FPGA is here, ASIC is here. So, which is cheaper at that point? FPGA. So, I will go with what option? FPGA. Let's say I want to manufacture 5000 units. Somewhere here 5000 will come, right? If you see in the x-axis, where does 5000 will come? After 2000, right? Which one is cheaper? ASIC will be cheaper because ASIC is coming here. So that means till one point, anything in this range, whatever I drawn now, FPGA is better. Once you cross this, ASIC is better. This is how companies will make a decision. Let's say you go to Qualcomm. What is the one type of chips Qualcomm manufactures? Mobile phone chips, right? So how do they decide whether should we use ASIC technology for mobile phone chip or FPGA? So what do? They will do the calculation, simple mathematics they will do. For manufacturing FPGA, what is the initial cost? What is the initial cost for ASIC? You know, right? That equation they will write. They know that, okay, cut off break even number is what? Let's say 10,000. Example, they'll come to number called as 10,000. Anything more than 10,000 if I manufacture, ASIC is better. So how many mobile phones will generally sell? Millions, right? Millions of mobile phones will sell. So that is why they will go with ASIC. In which case people will go for FPGA? Where less production. What are those less production examples? Aeroplane chips. You know, right? Aeroplane also will have a lot of circuitry. All the cockpit is lot of it is electronic circuitry only, right? So what they will do? They'll go with FPGA. Why? Because you don't do bulk production of aeroplanes. Maximum they will manufacture few hundreds in a year. How many aeroplanes they will manufacture? Maybe 200, 300, or maybe 500. So given all that, in that kind of low production areas, they will go with FPGA. So the cost of ASIC design flow is multi-million dollars, since we need to start from scratch. Once flow is working, per chip cost is less. Cost of FPGA design flow. Initial investment is less. It's like lakhs of dollars, since hardware is already available. Per chip manufacturing cost is higher. Even though the hardware is there, but that cost of that hardware is higher actually. ASIC versus FPGA. Any VLSI chip can be developed using ASIC and FPGA flow. Means if I want to make this mobile phone, it is possible that I can manufacture this mobile phone with ASIC style as well as with FPGA style. How do I choose? It is a simple calculations. I mean, I'll see what is it. Decision is based on the cost. Let's say ASIC based flow is $15 per chip. FPGA based flow is $50 per chip. Companies which manufacture products for bulk usage, they will go with what? Please read this once. So companies which manufacture for bulk uses, they will go with ASIC production. Companies which manufacture for limited production, they'll go for FPGA production. Let's now understand what are the advantages of ASIC over FPGA. We'll also discuss the other one also. FPGA also has some advantages. ASIC has more advantages. That's why companies prefer a lot of times ASIC. First advantage is cheaper. Per chip cost will be less. Consumes less die area, hence it is cheaper. Provides flexibility to customize the design features. It provides flexibility to customize. I mean, I will give you an example. ASIC is like, let's go back to house construction. ASIC is like starting everything from scratch. Foundation, the bricks, everything you are deciding. Each and everything you will decide. Starting everything from scratch. FPGA like prefabricated structures will be there. You know, we can construct houses using prefabricated structures. You can bring the structure and just customize for your requirement and keep the structure, and you change the structure for your requirements. That is FPGA. Which one will get over quickly if you want to do? Second one. But which one gives you more convenience to do? I mean, more customization. For example, in my house somewhere I want to keep window. The prefabricated structure may not give me that option. So I can completely customize how I want to design. That is where ASIC provides all that flexibility. Power efficient. See, in my, I may use some type of bricks which will give me more power, I mean cooling behavior in the house. Whereas in prefabricated structure, what he gives, I have to use it. Let's say metal structure he gives, I have to go with it. So I don't have much control on the power behavior, right? ASIC can work at higher frequencies compared to FPGA, hence gives better performance. So many advantages are there for ASIC over FPGA. What are the FPGA advantages over ASIC? One thing is what? If a chip has a bug, let's say you manufacture a chip, this has a bug, assume mobile phone. Every mobile phone of this chip will be waste, because this will go, that bug will be there in every chip, right? So if a chip has a bug and which is detected after manufacturing, FPGA style won't have a bigger problem, because you don't have to start everything from scratch. You can fix it in the next FPGA board. Whereas in ASIC we have to do the entire flow again. In FPGA we don't have to implement the entire flow. Bug can be fixed in the next FPGA board, another FPGA board. So we don't need to start from the scratch. In ASIC, if there is a bug, we need to do entire flow again. FPGA flow is quick. Since we don't start from scratch, the board is readily available. It takes less time to develop FPGA flow compared to ASIC. In fact, FPGA is used at one stage of ASIC design flow. I mean, there is a concept called as FPGA prototyping we do in the ASIC flow. Means what? Even in ASIC flow, companies do FPGA prototyping. Even when you are doing ASIC flow, right? Companies will do what? FPGA prototyping. What is done in FPGA prototyping is you first prove your design using FPGA board. Develop RTL code, program it on FPGA board, check if it is working, then it is working fine, right? It confirms that RTL code is working. Then go for ASIC bulk production. Please read it once. First step is what? Develop the RTL code. Put it onto FPGA board. First you prove using FPGA board that it is working fine. It won't cost you much because FPGA board is very cheap, relatively cheap, right? If it is working, it confirms that the R code is working, then go for ASIC bulk production because you know that it is working. See, instead of finding a bug in the ASIC, you can always find it in FPGA and fix it. That is called as FPGA prototype. So this is a brief about what is ASIC and FPGA. Here I have written some cost calculations. Let's not get into it. I mean, how do you decide when to go for ASIC and when to go for FPGA? This we can kind of ignore. You got the idea, right? So in summary, you need to understand that to manufacture any chip, there are two styles are there. In ASIC, everything starts from scratch. In FPGA, you start from a specific board. In ASIC, you go for ASIC if you need bulk production. You go for FPGA, you need when you have limited uses. So these all things we have discussed. Okay. Talking about design flow for ASIC and FPGA, the front end domain flow is similar between ASIC and FPGA. Between ASIC and FPGA, the front end domain flow is similar. See that RTL design, the integration and verification is very similar. In both the cases, user need to understand the specification. You implement the design using Verilog or VHDL languages, and the functional verification using SVUVM. They are all same. Where do they differ? Where do ASIC and FPGA differ? Majorly, they differ in the backend domain flow. The flow starting from physical design to custom layout. For example, in what is meant by physical design? Floor planning, placement. There are multiple steps are there. Majorly in the backend domain, they differ. Front end domain is similar between both ASIC and why is this topic is important is I mean why term FPGA is important here is that most of you who are joining are for ASIC course actually, that is RTL design and verification course. You should be aware that there is another domain called as FPGA domain. Okay, this is a domain where there will be less competition because people mostly don't join FPGA course. The number of jobs when they are there, less competition will be there for FPGA jobs. Again, let me repeat. In FPGA domain, there are opportunities. It's not like every company is ASIC. It's not ASIC. Around 85% companies are ASIC. How many percentage of companies work in FPGA? Around 15%. But number of people who take FPGA course will be less, very less. Hardly we have 30 people doing FPGA entire year. Okay, but the number of opportunities are relatively better compared to ASIC. So that is where you should always look at FPGA also as a one important option. You should not take because everyone is taking one course. You should not take, right. You should explore what is the market, where there are better, where there is a better chance of getting a job. You should always explore that. Okay. My domain is ASIC. My other trainer teaches FPGA. So still I am suggesting because you should do all that homework. In the institute, you get a time up to 2.5 months. After 2.5 months also, you can decide whether you want to go to ASIC or you want to go to FPGA because that initial 2.5 months is common course. The final 4-5 months course, you see, last 4-5 months is where you differ. See, in one case you learn ASIC verification concepts. In one case you learn how to develop RTL code, how to put it into the FPGA board, how to do the complete implementation on the board, how to do the timing closure. That aspects you learn in FPGA. So if you ask me, does FPGA has good opportunities? It also has very good opportunities. At one point, FPGA is better because you finally build the product. Okay, let's say 4-5 of you learn FPGA very well. You can start your own small company where you start making your own FPGA boards. Boards means what? Board is already there. You conceptualize onto the FPGA board and you can sell the board. I'm telling what is that you could do. In ASIC, you cannot do all that. Why you can't do? Tell me. It will require some crores of rupees. To do anything in ASIC, it will require crores of rupees. In FPGA, you can manage in few lakhs because you can buy a board, you develop a RTL code, you program it onto the FPGA board, and you can market that board. So that is possible. I'm not telling that today only you'll develop board. Over a 6 to 8 months time, when you learn gradually, you learn it. So I'm telling that keep always option open because everyone takes verification course. Don't take verification course. What happens when there are 10 opportunities, when there are 100 people, you'll find it difficult. There FPGA is one domain where there are less people are there, very less people. It's not that no jobs are there. Jobs will be there definitely. FPGA, because if company works in FPGA, they need FPGA engineers. They need skilled people. If you tell that I know FPGA's full form is this, they won't hire, right? They'll hire if you are able to do that flow, where you are able to put it onto the Xilinx board or Altera board, and you are able to do the floor planning on that board. I mean, you decide which block will come where, how to do the timing analysis. So that skill set, what you are going to develop. So accordingly, you decide. You don't have to decide today. You can decide after 2.5 months also. But take all this into consideration. Okay, just because another 100 people are taking, don't be the 101% to take that course. Always think what is the market, where there is opportunity, and accordingly take that course. Okay. Now let's go over some questions. Yeah, Vartika, please ask your question.
Sir, I had one question. Do we need for like FPGA designing? Do
Yeah,
we need the knowledge of C or C++, like programming language?
you need only Verilog or VHDL.
So to design FPGA boards.
See, you don't design FPGA board. See, FPGA board is already available
No,
in.
sir, you
No, no,
just
I
now told
didn't.
no, like we
No,
can
no.
design our own FPGA boards.
See, I'll tell you. To to sell a FPGA board, what is that you will require? I'll tell you. Okay. FPGA board involves three aspects, right? At least two aspects. One is you buy a FPGA board. Let's say this is FPGA board, or let's take a FPGA board that is available in the market only. You should think in that direction. Actually, how can I, over a 2 years, how can I develop my own FPGA board and how can I sell? See, if you target that level, where will you reach? You will reach a point where at least you are a very good engineer, where you can get into a job and start working. You understand that? Is it not possible to develop your own FPGA board? You start with a simple thing, very simple logic. Then once you learn the flow, you can start implementing little complex things. Okay. Assume this is the FPGA board. This board is readily available. That is what we know. Okay. In this thing, when you say this is already available, it is not customized for any functionality. You develop a RTL code. RTL is done in which language? Verilog language. That you convert to gates. That you convert to what? Gates. That gates will be synthesized into, programmed into this board. Whatever gates you converted, right? AND gates, OR gate, that will be programmed into this one. Somewhere inside this. Some of them will be analog components, some of them will be digital components. You are going to basically put your logic onto the FPGA board. Now, do you think can you sell this board directly now? You can't sell. Why? Because it only has a hardware now. To sell it, can I sell this just as a hardware? What else I need? I need to have the drivers. I need to have the OS kind of. So all those things you'll have to do. So there will be some kind of memory where you will have to load your drivers and operating system. You have to decide what is your target market and accordingly work in that direction. This is the kind of goals you should be looking at. When not tomorrow, not after 1 week, where 3 years down the lane, I should be doing something like this. That should drive your learning. Then what will you start learning? What is meant by OS? What is meant by driver? How does hardware work? How to write a code? How to convert it into the code? How to put it onto the board? Then you will start learning. So your target should be bigger thing. Then you will start learning small things and connecting those small things. So for me to come out with a FPGA board after 3 years, what knowledge do I require? I require how to learn FPGA board, how to develop a code which I will be putting onto the FPGA board. How will I boot up the FPGA board? So even FPGA board need to be booted up, right? So those are small things you are going to learn. Okay, now internet is so, I mean, information is so much available that it will make you do everything also. That is how you should be looking at it. Okay. Anyway, you don't have to decide on this all by today. After 2.5 months also, you can decide that this is what I want to get into. Okay. Yeah. Vartika, is it clear to you? You still have, I mean, did you get the clarity? Now, if you ask me, do I need to know C language? Yes. How much? To develop the drivers. You need to develop the drivers, right? That need to be converted into assembly code. And that assembly code is what you have to load into somewhere in the memory. See, somewhere in this memory, somewhere, let's say this is the memory, assume. You may have to load that assembly code. And then this processor will start executing those instructions. C++, you don't need to know.
Okay. Okay, sir.
Okay. Any other questions?
Any other
So the
questions, please?
the verification process is same as like this FPGA and as far as the other things
Yeah,
like
verification process
UVM
will be
and
similar. Yes, verification process will be similar. Yeah. One thing, everyone, once you please fill this form. Okay, I'm sending one form in the Google chat. Sorry, in the meeting chat window. You can fill that form towards the end of the session. Okay. Yeah, please ask your questions. Yeah, verification process will be similar because in both the cases you are going to develop the Verilog code. You have to verify in both the cases. So the same approach we can follow. Any other questions? If you had some questions earlier and I missed out, you can again ask me now. This August 25 is not the date, August 2025. Okay. Any other questions? Fine. So I hope you got some basic idea about ASIC FPGA thing. Now let's talk specifically about ASIC design flow. In case you are interested in FPGA demo session, you can connect with our admin. He will tell you the schedule for FPGA demo session. There will be a separate demo session where you can ask all your queries. What will you teach? Will you teach me how to develop RTL code? Do you teach how to put onto the FPGA board? Will I be able to bring up the FPGA board? Everything. So you can ask all your queries. He will answer. Anyway, he will cover that. But on top of that, you can also ask your queries. Let's now understand the ASIC. I mean, my whole point of pushing FPGA is that you should be looking in the current market is such that you should not be looking at getting job somewhere. You should be looking at a point where can I develop my own small things. When you start looking at that level, you anyway become employable, right? If you look at a bigger picture, what is a bigger picture I'm talking about? Develop your own product. In that process, you learn everything. What will you learn? How to develop the Verilog code, how to convert it into gates, how to put it onto the FPGA board, and how to bring up the FPGA board, how to make it function. So automatically you become employable also, right? You can get into any job and work. So I'm telling target that. If not, you don't reach there, you will anyway reach the other level where you definitely will get a job. Yeah, Banu, please ask your question.
yeah. So will you give the video sessions if I selected any one of the course? Let's say if I selected the ASIC, I've not selected the FPGA. Will you support to give some video courses to understand the other side around?
See, basically, whatever course you enroll, let's say you have enrolled for ASIC, that is the RTL design and verification course, you will get access to all those videos. Today's session, whatever I'm doing, it is being recorded. This session is being given access to you for a specific period of time. But if you, on top of that, if you need FPGA access, that's separate cost. Our team will tell you what will be the cost for that. Does it answer your question?
Yes. Thank you.
Next, what is the difference between implementation use cases? I believe our FPGA trainer is the best person to answer this. He is asking what are the difference between the implementation of certain use cases like IoT, microcontroller, and FPGA. Microcontrollers and FPGA. I didn't understood the question completely. Use cases like IoT. Can you please elaborate this question?
Arvind, microcontroller versus FPGA. See, even I believe eventually you are implementing that microcontroller onto the FPGA, right? When you are doing FPGA style, your question rather should be ASIC versus FPGA. I mean, how will you approach IoT implementation on ASIC versus FPGA? ASIC, you know, right? You come up with that standard circuitry and do that. When it goes to FPGA, I believe they will decide what kind of digital components are required, what all analog components are required. See, IoT means some analog behavior is required, right? You are interfacing with the external components. When you are interfacing, you need some analog circuitry also. So accordingly, they may decide. My suggestion here is please attend FPGA demo session. In this case, talk to the trainer. He can clarify more from a FPGA perspective on this one. Okay. What all things we are going to study in functional verification, I will be covering that in the later part of the session now. Okay, so we will go through the another half an hour, we'll go through the things, then I'll take up any other question and answers. ASIC design flow. The ASIC design flow, let's start with the simple analogy of the ASIC design flow. ASIC design flow is similar to a house construction. It starts with what? Requirements. What is the requirements? Basically, what kind of house you need. Then whom do you go to? Architect. You go to architect. What architect will give? He will take requirements as input. Requirements become his inputs. He will give you the different plans, architecture diagram, and various plans he will give you. Then you will go to, let's say, contractor or masonry. So for him, this becomes the input. For the contractor, this becomes the input. So it's like when you are in the flow, whatever is the output of the previous stage, it is input to the next stage. Same thing with VLSI, exactly same thing. Only difference is, in this we are constructing a house. In our VLSI, we are constructing a chip. Instead of constructing, we should call fabricating a chip. Like that, you see, so many people are involved. So many people are involved in the house construction flow. Similarly, in ASIC design flow also, there are many people are involved. Many activities are involved. Which starts from where? Requirements. What do you need from the chip finally? What kind of performance you want? How many USB ports you want? What PCI Express generation you want? Everything they will decide. Okay. Then it goes to whom? Architect. What architect will give? He will give the architecture diagram. He will give the architecture diagram. Then it goes to RTL design stage. Then integration, verification, then DFT, design for testability, done at the RTL level. Then it goes through the entire backend domain. That is synthesis, DFT, physical design, static timing analysis, custom layout, physical verification, GDS2, fabrication, so many things. I am not expecting that you should understand everything. Right now, if you just remember this flow, that is fine. At the end of today's session, I don't expect that you should know what is physical design. I don't expect that you should know what is static timing analysis. That is what we are going to cover, right? I mean, when you go for front-end domain training, you're going to get a feel of everything. What is meant by design, what is meant by integration, what is meant by verification. So finally, once you do the packaging, this is how your mobile phone will come. So can I start using mobile phone after packaging? No, because it's only hardware now. It is still, what is it? Hardware. What else it requires? Drivers of operating system. Then once it comes to your hand, applications. So that is when it is ready for use. Let's now briefly talk about the front end domain flow, because in ASIC flow also there are two major things. One is front end domain, one is back end domain. So now this demo session is focused on what? Front end domain. So let's understand what is VLSI front end domain flow. VLSI front end domain is similar to software flow. What is a skill set required for a software engineer? C, C++, Java, some programming languages they need. Should be good at reading software specification. The software engineer should be good at reading some documents, right, which explains how software will work, and develop algorithm, implement that using C or C++. Understand the algorithm, come up with the algorithm, implement that algorithm. Should have good programming skills. Similarly, for a VLSI front-end domain engineer also, you should be good with Verilog, System Verilog, and UVM, like you have C. Similar to C, you have to learn a language called as Verilog. Similar to C++, System Verilog. Similar to Java, UVM. UVM is not as complex as Java, very very easy. But you should have that inclination to learn the coding. Should be good with programming or inclination to learn programming. See, if you hate programming, then front end domain you should never choose, because you will be doing some coding every day. Without knowing without having any interest in coding, you cannot do this course. Should be good at reading the hardware specifications. Please read it once. Reading the hardware design specification, understand design functionality, implement the requirements using various protocols like USB, PCI Express, DDR, various things. So in summary, if you want to get into front end domain, the course you are looking right now, this is the skill set you will be looking at. You don't need to learn this skill set in 1 week, 2 weeks. You need to learn all this skill set over 2 to 3 years time. Our course will give you all the required guidance. We will start from very basics of digital design, very basics of Verilog, very basics of system Verilog, and we will move on to the advanced aspects. Yeah, like Vijay, functional verification and design verification both are same. Where does VLSI differ from software? I said in the previous slide, I said software is similar to VLSI front end domain. Now the question is, where do they differ? Back end domain. In software, there is no back end domain. Let's say I'm developing some billing software. You know, right, in hotels and restaurants, they will use billing. Let's say I know some programming, I can develop a billing software. I can sell the billing software. Will I sell the code or will I sell a chip? When I have to sell a billing software, Only software. I'm not going to sell that entire machine. Will I sell the soft code or will I sell the chip? Code only, right? Because I developed a code, I'll ask them to install this soft application and use it. I'll give an executable file. Like you buy anything, you get some executable file, you install that executable file, right? Same way, whatever I develop, I convert it into executable file using compilers. I'll sell that. So that means what? In software, you don't need to manufacture a chip. Does Infosys manufactures any chips? No. Why? For them, their work stops once they developed a software and tested that software. They have done the testing of software, their work has stopped. Whereas when you want to buy a mobile phone, will you buy Verilog code or will you buy an actual phone? That means in VLSI, there is a backend domain where it has to go through the other process of converting the code into chip. Whereas in software, it stops at testing level only. Once you have tested the code, it is done. So that is where they differ. Software doesn't require backend flow. The backend domain flow means what? The process of converting RTL Verilog code into chip. Once you have a Verilog code, you have to finally convert it into a chip. That is called as backend domain. In software, the code is installed and used. No need to manufacture as a chip. In VLSI, the functional verification plays a important role. If there is a bug in the chip, which is detected once it is in production. Let's say I have taken this to the production and there is a bug. I cannot do anything. I have to redo the entire process. I have to go through the starting process and again manufacture the chip. Whereas in software, what happens? Tell me, I purchased a software. There is something wrong in the software. What do? They will give me updates called as patches. You know, right? They will release software patch. So I install that patch, automatically my code will work. My software will work properly. So that concept is not there in the chip. Let's say if a mobile phone has an issue, it is gone. If it is a hardware issue, I cannot put a patch on that. The entire flow needs to be done again. VLSI chips don't have a concept of patch. In software, if there is a bug, it can be fixed and released as a new version of the software. That is called as patch. Let's briefly talk about different job roles in the VLSI. What are the different job roles in VLSI? Front end domain, back end domain. Okay. I will take all the questions in some time. First, let me go through this topic. See, these are the different job roles. The person who gathers the requirement is called as marketing team. The person who does the architecture is called as chip architect. He architects the chip. The person who does RTL coding is RTL design engineer. Person who does integration is RTL integration engineer. Person who does functional verification is functional verification engineer. Person who does DFT is the DFT engineer. Synthesis engineer. Like that, for everything there is a corresponding person. The question is, why do we need so many people? Can't we have one person? Like you go for a house construction. Does painter do the carpenter work? Does carpenter do plumber work? Everyone, they do their own work, right? They don't do other work because they have that specialization. They understand that subject. Same thing in VLSI also. If I am a physical design engineer, I am expert in that. I don't have any expert with other domains. Companies also hires like that. Let's say you want to construct a house. Will you have one person do everything for you, or will you hire individual people? We'll hire individually one who is good at carpentry, one who is good at electrician. Like that you will choose, right? Same thing here also. Companies don't hire a person who knows a entire flow. They will hire when you are expert in one particular domain. It can be RTL design, it can be RTL integration, it can be RTL verification, synthesis, any domain, but you should be expert in the domain, then only companies will hire you. Okay. Gaining expertise is not a very complex thing. Okay. It is time you have to spend. Let's say I want to become expert in functional verification. It's not a very complex activity. You need to give time, you need to have that patience. Means you should keep a timeline. Let's say, okay, 1 year time. I have to become expert in functional verification. That's a very realistic time. In 1 year, you can become expert, very good with functional verification. That requires a little bit of planning. So that is the guidance we are going to give you. Okay. Am I telling that your training should go for 1 year? No. All I'm telling is, let's say we teach for 7-8 months. Still, there will be things that you will have to learn. We can't teach entire functional verification in 8 months also. So your learning will always be there. You should just be focused in that direction. Let's understand ASIC team distribution. Means what? Let's say assume you are getting into one mobile phone SoC project. Get into one mobile SoC project. Let's say total team size is how much? 50. Let's understand how out of 50, how many will be front end domain, how many will be into back end domain. Front end domain will have roughly 25 to 30 people, little more than back end domain, which is how much percentage? 50 to 60%. Out of those people, how many is architects? Only one architect. Like you are constructing a house, there are almost 50 people are involved. You know, right? Laborers, masonry, painter, plumber. If you count, how many people will be there? 50. How many architects were there? Only one architect, right? Did you go to 3 architects to give 3 architecture diagrams? No. Only one architect. Design team will also be small actually. Maximum 4 to 5 people. Why? Because in design work, they don't develop from scratch. They will use existing components called as IPs, intellectual properties, IP. Existing design IPs only they will use. Because of that, you don't need many people. If I'm developing everything from scratch, I need a lot of people. If I'm using existing components only, I don't need many people. That is where it needs less people. What about functional verification? What about functional verification? Tell me. It requires a lot of people. How many? 15 to 20 people. That's around 30. Question is, why do they need more people? Why do we need more people in verification? Because when you are doing design work, even if you have done small mistake in the connections, anything, my chip won't work finally. Even if you have done a small mistake in the chip, it won't work. So to make sure that everything is working, you need more verification people. Okay. In VLSI, verification also holds a lot of importance. You see, go to software, there's a clear differentiation. Developers are treated high, they are very important in the job role. Testers don't have the same importance. Go to software, developers has a lot of importance in the team. Testers don't have equal importance. Whereas in VLSI, functional verification has engineer also has a similar importance as design person. Because if functional verification misses any bug, it finally goes into chip. You cannot fix the bug. Whereas in software, even if tester misses a bug, you can again release a patch and fix it. Coming to backend domain, backend domain will have what? Remaining people, 20 to 25. DFT will have around 2 to 5 people. Physical design again has more people, 10 to 15. STA has less people. So here what happens because of this is, which are the two domains where more people are required? Verification and physical design. That is where companies will have option to hire freshers. If you go to architect, can a company hire a fresher? All right, because you have to architect. So will they hire junior level person? They'll hire very high experience. So there you don't have option. What about design team? Already less people are there. Maybe they'll hire one fresher, but mostly they'll try to keep experience. So this is where they have option to do that. They can hire freshers. After 6 months, you start performing as a experienced person. So that way they can bring up the team. That is where functional verification and FP physical design has better opportunities for freshers to get a job. A brief about what is DFT. Very brief. I'll only keep it for 2 to 3 minutes. Okay, because this is not a DFT demo session. There will be another demo session for the DFT. I want to just give a brief. DFT stands for Design for Testability. What is design for testability? I'll tell you in simple terms. Let's say into this mobile phone, one chip has gone. This is the chip that went into my mobile phone. If the chip has some manufacturing defect at the time of fabrication, right? Some bug happened here. What bug happened? I'll tell you. This line ended up connecting to voltage always. It's like it so happened that when I'm designing this house electric connections, one wire always got connected to power supply. Whether you switch off the light, switch on the light, it doesn't matter, it will always be on. Is it correct design? No. Something like that happened inside the chip. Something like that happened inside the chip. How will you detect? Let's come back to the room example only. Just you come to the room, can you detect there is a mistake here? How will you detect? You will go to each switch, you turn on, turn off, turn on, turn off. Same thing we do in testing also. We apply some inputs to the chip. Based on the outputs, we know whether the chip is good or is it bad. The person who provides those inputs is the DFT engineer. The person who provides those inputs is the DFT engineer. He uses some techniques called as scan, ATPG, built-in self-test, JTAG, various techniques he will use. And through those techniques, he will generate some patterns. What does he do? He generates some patterns. Based on that, he will detect that. He will give some those patterns. Those patterns are used by post-silicon validation engineers. Two people are involved here, you see. DFT engineer is the person who gives those patterns. Post-silicon validation engineer is the one who does this work actually. Like applying the inputs, checking whether it is behaving correctly or not. So what is the role of a DFT engineer? Give the patterns. To generate these patterns, what techniques he uses? Scan, ATPG, built-in self-test, JTAG, various things he uses. What about post-silicon validation? He won't do anything like that. His work is what? As a DFT engineer, I will give him some patterns, some data I will give. He will apply those things here. He will debug the chip. Okay, is it working fine, or does it has any fault? All those things. The same thing explained. So chip can have different types of defects, stuck at fault, at speed fault. What does the DFT engineer do? Develops test patterns which help detect the manufacturing defects in the chip. Example, sample test pattern is, let's say, 1010, some pattern is there. This pattern is applied to the chip. Chip output tells whether the chip is good or faulty. The DFT engineer uses various techniques to generate above test pattern. So DFT engineer uses some techniques. He won't randomly generate these numbers. Okay. That number 1010 is not a random number. It is a very well uh, developed in a specific process. What are those process? Scan, ATPG, BIST, JTAG, boundary scan, compression, various techniques he will use. Through that he will generate these numbers. These vectors are given to whom? Post silicon validation engineer. Means what? Post silicon means what? Once the silicon has come, he is validating. That's why post silicon validation engineer. What is the role of a PSV engineer? Apply these test vectors to the chip using a tester. Output of the chip indicates if it is working fine or if there are any manufacturing defects. If there are defects, chip is not used for packaging. Let's say I found that this chip is faulty. Will I still make a phone? No. I will throw it off. If the chip is good, then I will use it. This percentage of good chips is called as yield. What is the yield means what? How many good chips have been fabricated? Out of 100 chips, if 82 are working fine, then what is the yield? 82%. So this is a brief about DFT. Let me just take another 10 minutes, give you a brief about what is meant by functional verification, because that is the domain you are attending. The training you are attending is for what? Functional verification. Let's try to very briefly understand what is meant by functional verification. So I am going to a design called as Ethernet MAC. What is the design I am going to? Ethernet MAC. Inside that, which folder is it? Verilog. So what is that Verilog? Is it a language or is it a component? What is it? It's a language. Using Verilog language, I have developed so many files. Different Verilog files are developed. What is the file? V file. Means what? Verilog file. Let's say if I take one of these blocks. Someone has developed this Verilog file. Okay. By mistake, which line number I am in? 214. I have done a mistake. Tell me what is the mistake I did? Replaced and with what symbol? Understood? Now I will come back. Tell me where is the mistake? You tell me where is the mistake? You know 214 because I changed in line number 2. So if someone tells you that there is a mistake here, fine, you can do. What if there is a bug and people don't tell you where is the mistake? You don't know whether there is a mistake or not there, you don't know. What is the problem now? If I don't verify it, whatever mistake I have done, I don't verify that mistake. That comes into my finally my mobile phone, let's say has some or laptop has a Ethernet port, right? It comes. What will happen? In some of the scenarios, my Ethernet won't work properly because that logic is gone wrong, right? Somewhere the logic for generating this signal has gone wrong. It's not like every time it will fail. Every time my Ethernet won't fail. Once in 1,000 times or once in 100 times, based on what is the criticality of the mistake. If it is very critical, every time it won't work. But in some cases, it may work 99% of times, but it will fail 1%. Will you still buy that product? All right, you will not say that, okay, working 99 times, 1% I'll ignore. You won't say, right? You will still not buy that product. So what is the role of a verification engineer? To find this bug. So can I go through this code and tell you this is fine, this is correct, this is wrong, this is correct, like that? Can I tell? Can I tell? Is it possible to look through all the files? See, this I missed corrected. Okay, I go through one more file, I go through this code. Can I go through each line and tell this line is correct, this line is correct? Can I tell like that? It is not possible, right? I can. I hope it is fine for the online participants now. Can you hear me now?
Yes, sir.
Yeah. So what is the role of a verification engineer? He cannot go through each line and confirm that. So that is where he follows some process called as functional verification process. As part of that, we develop something called as test bench architecture. What does he do? What does I do as a verification engineer? I develop my own reference model. This is the design that I got. For both of them, we apply inputs. This will give me actual output, design output. This will be the output I am expecting to get. I compare both of them. If it is working fine, good. Otherwise, problem. Let me again repeat. Let me again repeat. We are looking at some Ethernet Verilog code. Assume somewhere inside that code there is a mistake is there. That means what? Somewhere here there is a mistake. So as part of the verification, what we do is we have the design. As a verification engineer, I will develop my own reference model using generator and BFM, scenario generator and BFM. We apply some inputs. If there is some mistake inside the code, there is some mistake inside the code. See, AND gate I changed to OR gate, something I did, right? That will come as a mistake here. When it goes through that path, my output will come with a wrong behavior, right? Whereas same input when you're applying, it will come as a proper output. When you compare both of them, what will happen? They will mismatch, right? Because one is giving wrong output because of this mistake. One is giving a right output. Will they match or don't match? Your role is to do that. Your role is to create test cases which will check this every part of the chip. See, the bug may be here, bug may be here, bug may be here, anywhere in the design, right? Can you say that bug is only at that point? No, right? The bug can be at any place of the design. The bug can be in any place of the design. So your goal is to create multiple test cases. Multiple test cases you are going to create, which is going to bring out that red mark. What is the red mark? Some wrong behavior that will come outside the chip as a wrong behavior. Because if something is wrong, output will come wrong. But for your design, the one I have implemented, it will come out properly. You compare both the outputs, you know that something is wrong. Then you have to actually trace and reach this point and figure out that this is the mistake. Two parts are there. What is the first part? Develop a scenario which will help you create this mistake, which will help you identify the mistake, that something is wrong. Once you identify that something is wrong, you have to pinpoint where is that something is wrong, where is it wrong. That is the role of a functional verification. Let me again repeat. Yeah, please ask.
So, but actually, when verification, how verification designer can make a reference model?
Because I have also design specification. Whatever document design engineer has, I also have same document. He will read through the document. He will develop the DUT. He will develop the design. I will read the same document. I will understand myself. I will develop my own code called as reference model.
But sir, according to that, freshers are in design engineering because reference model is you are taking reference from a perfect thing.
No, no. Only difference is this is done using Verilog language. This can be done using any language, system Verilog UVM. So you don't have to follow all the rules of a RTL design. You develop a model, how it should behave. Basically, developing the reference model is easy compared to RTL code, because RTL code lot of restrictions will be there. In reference model, there won't be many restrictions. There will not be many restrictions. Let me repeat again. Let's write the notes. Design specification is input to both design team how many teams are there? Two teams. What are those two teams? Design team and verification team. Okay. What does design team develop? Verilog RTL code. This is that. This block you see shape that crossed ones. That is the Verilog RTL code called as DUT. That is design under test. The verification team develops reference model using system Verilog and UVM. It is much easy to develop, much easier to develop, because you are using SV and UVM. It becomes very easy to develop it. Rule is simple. Whatever inputs you apply, same inputs you apply to reference model. Then what will happen? You will get how many outputs? Two outputs. This output is called as what? Actual output. This output is called as what? Expected output. You compare both of them. Will you apply only one output or many output? Sorry, will you apply only one scenario or many scenarios? Many scenarios. Because if the bug is there here, let's say, do you think some scenario which goes through this path, will it catch that bug? Some blue line is going through some other path. It is not going through that red line, red cross. You see, it is not going through that path at all. Will it catch that one? No. So you should be exercising many scenarios. Let's say I've created 4. Out of 4, how many are actually going through that cross? Only 1. So when you compare now, out of 4 test cases, how many will pass and how many will fail? 3 will pass, 1 will fail. Your role will be to develop such test cases. See, I can say that my verification is completed by developing only 3 test cases. Is that correct? No, right? I missed one bug, right? I missed one bug. So your goal is to identify how can I target all those possibilities and make sure the design is working. That is where we follow a proper process. Read the specification, list down features, come up with test plan so that you don't miss anything. See, your goal is what? To not miss anything. Your goal is not to say that I have done coding and I'm done. Your goal is to say that there is no bug in the design. There is no mistake in the design. Did you get a feel of what is verification? My idea is not to teach you entire verification. It's not possible now. To tell you what is meant by verification. Now let's go to the non-technical part, that is the schedule, the other things. Okay. Training schedule. Okay. Once this is done, we'll go through the question and answers. Mode of training. Some of you are attending offline, online, that is all possible. The training is available in full week, weekends only. In some cases weekdays evening, but currently it's not actively running because we need some minimum strength. It is not there right now. We can even do customized one-to-one training. Okay, customized one-to-one training is it's like we have a one-to-one trainer for entire course also. In full week, online, offline, and hybrid model is available. Means online you can attend entire course online. Offline you can attend entire course offline. Hybrid means sometime you can be online for a month, for a few weeks, then you can again switch to offline. That is all possible. In this mode of training, you will have access to the recorded videos for revision purpose. I mean, everything is live training. Nothing is video. Video is given only for revision purpose only. Weekends only training. Weekend only training is only online sessions. Dedicated mentor for offline doubt clarification. Let's say you are attending online, but you want to come to institute and clarify some doubts. That you can come as a offline support session. In weekends only mode, you will have access to all the recorded videos for entire course duration. Here it is only for limited duration. In weekend only mode, entire duration you will have access to all the videos. Other than that, you can even go for customized one-to-one training. Schedule and session timings are flexible. Course content is also flexible in one-to-one training. That's why it's customized.
Sorry, Srinivas. So, like, can you repeat weekend only? I missed something.
See, weekend only. Most of the people who attend weekend training are working professionals. Many, in our experience, they want to attend it online. So it will be on Saturday and Sunday. But in case you want to come to the institute and clarify some doubts in person, we will assign a dedicated mentor for doubt clarification also, where you can come to the institute and clarify your doubts. Is that clear to you?
So there will be no live video sessions on weekends. You will give
No,
only
no,
the
no,
video
no. It is
recorded.
there. You see, it is there. I said online sessions, live online sessions over the weekends. Let me write it like.
Okay. Okay.
In all modes of training, every student is assigned with a dedicated mentor for doubt clarifications. Uh, let's briefly talk. The functional verification training will go for 8 months duration. During this period, 6 days per week, Sunday will be off. 5 hours per day. Out of that 5 hours, 2 hours will be theory session, 3 hours will be lab session. Every session recorded video access for 2 weeks. We have one portal called inskill.in where you get all the learning materials, everything. You will also get the printed material of the course content. All the course presentation, assignments and notes are uploaded to this portal. Printed material provided for all modes of training. Even if you go for online training, the material will be posted to your house address, postal address. Training is divided into 3 phases. Phase 1, which will go for 2.5 months. In that, phase 2 will go for 3 months. Phase 3 will go for 2.5 months. Let me just go there and clarify. We'll also cover Verilog language, Verilog projects. We'll also cover STA. In this 2.5 months, we will teach advanced digital design, basics of STA. You don't need to know everything of STA. STA stands for static timing analysis. So you need to know whatever is required, that will be covered. Other than that, we'll cover one tool called as GVim, text editor. Okay, text editors. Then we'll also teach Verilog language and Verilog projects. All these things will be done in the 2.5 months. Later 3 months, and every week, two soft skill sessions every week for entire course duration. Means there will be I mean, you know, right, soft skill is anything outside the technical part. It could start from how do you attend interviews, uh, how do you write your resume, okay, how do you attend a team meeting, how do you write email, anything, right? All that will be covered. So we don't do that session at the end of the training, like 1 week soft skill training. That won't help. Rather, it will be continuously guided one, where starting from the day one, trainer will tell you how to prepare. uh, it could be anything, right? uh, I mean, how to take care of your job preparation thing. Like, you go through a lot of pressure, right? I mean, when will I get job? So it could address any kind of things, right? It's like there are things which you didn't learn at the tech stage. Few gaps are there in your overall communication skills and soft skills, right? That will be addressed. So it's not like that will be done only towards end of training. It's a gradual process, right? Let's say some of you are not having proper English speaking skills or maybe communication skills. You don't know how to present your concept. It's not about English. It's about you can talk in your own native language, but you don't know how to communicate your idea. So that need to be learned over a period of time, right? You cannot learn it in 1 week. In 1 week, you cannot become expert with how to talk. So those kind of things will be done for entire course duration. There is a one dedicated trainer for offline soft skills, one dedicated trainer for online soft skill training. So those attending on offline, that trainer only will cover like that. Okay. Then these phases will be there. Phase 2 will cover system Verilog UVM. And as I said, soft skill training is a regular ongoing thing. It is not particular to any duration. Okay. After this, the placement support will start. After 5.5 6 months, your placement support will start. And after these two, there will be 1 month of dedicated interview focused training. Before we start the projects, before we start with the project, we'll do 1 month dedicated interview preparation training. What happens is, what you did today, after 5 months you forgot. Not even 5 months, right? After 2 months you don't remember many things. So this 1 month revision session is for all that. Actually revise everything from digital design, Verilog, SV, everything again, so that you are prepared for the interview. You should not go to interview and tell digital was done 6 months back, right? So to make sure that it doesn't happen, we have a dedicated 1 month training. So the duration will be very long, the 2.5, 5.5 months, 6.5 months, 9 months. Here itself it's going for 9 months. That's okay. Reason is you are anyway getting placement support from the 6th month already. After that you are only going doing projects. Even if you get a job, if you get a job also, there also you can do project. Our point is that even if you spend more time, you should go out. When you go out, you should go out with a proper knowledge. That's the idea behind long durations. uh, like revision of everything, important questions, everything will be covered in this thing. The final phase 3 will be this. I will call phase 3. This will be the phase 4. That is 2.5 months. There we do multiple industry standard projects. Projects on AXI, AHB, Ethernet. We will also teach you Python scripting, SOC flow basics, everything. So this is how the entire training is divided into. This is kept purposefully long. My point is, do we need really 9 months training? Many times you require, because the people who come, they don't know what is K-map properly. They don't know what is meant by POS representation. Let's say De Morgan theorem. I mean, right? I am talking about very basics of digital. If it go to what is flip flop, what is JK flip flop, what is SR flip flop, how to implement some counter using flip flops, implement some other circuitry using flip flop. People don't have that basics. Can we teach all that in 2 days, 1 week? You have to spend time, right? Minimum 3-4 weeks we have to spend. Same thing with Verilog. To teach properly, we need to spend minimum 1.5 months. That is where this will require 2.5 months.
Yeah,
We
hello.
cannot reduce. I cannot reduce that time at all. System Verilog is very important because many of you don't know what is object-oriented programming. We need to teach very basics of what is object, what is class, what is inheritance, what is polymorphism, everything. Then I have to teach UVM. I cannot reduce this 3 months also. Revision I have to do because most of the people don't get time to revise the things. We have to have a dedicated time where we make them revise the things again. Because otherwise when you go to interview, you miss the opportunity because you didn't revise at all. Then we have to do projects also. Why projects? The companies have a lot of people to hire from. See, the market has a lot of people, right? I mean, there are so many institutes. So when whom they will hire? Someone who comes with a better skill set, right? I mean, someone who has more than UVM knowledge. It's not like only I know Verilog UVM, I know projects. That is what this will focus on. This may not be the case in many institutes. They may end up finishing in 5 to 6 months. We have done training in 6 months also. See what happened, we have done for one company in Bhubaneswar. Most of this work finished in 6 months. What that company did is they went to each college, pick top 3 people. They pick up immediately. Even before I tell them to do, they will do the work. They will start their work. Even before I tell the subject, before only they will prepare and come. There it's possible to finish in 6 months, but many times people who come to the regular batch has some skill set gap. To fill that gap, we need to spend more time. Okay. Uh, See, basically this is structured in such a way that once you learn everything, even if you spend 9 months, that is worth it. You should not be discouraged. You should not be thinking negatively that why I'm spending so much time. You should be looking at it. What is the skill set I should go out from the institute? I will be employable. I'll be happy if you go out in 5 months also. But my way of looking, our as an institute, our philosophy has been that if the person should be trained with a proper skill set, so that companies should not feel burden. If you join a company, they should not feel burden, he doesn't know anything and he joined our company. That's a problem, right? So we want to make sure that that problem don't happens. Many institutes don't spend so much time actually. For different reasons, they won't spend 9 8 9 months. They try to finish it in 5 to 6 months, which is really not sufficient. Experienced people also will have similar schedule. Only thing is, what is the difference for experienced engineers is, for them, no digital and no Verilog, because already they are working in the industry. So we assume that they are fine with Verilog and they are okay with digital. So their training directly starts with system Verilog and UVM and projects. So hey, their schedule will be only for 6.5 months, not 8 9 months. Again, don't think that you have to wait for 8 months to get a job. If you are capable, you can easily get a job in 5 to 6 months also. Similar for FPGA. If you want more details about FPGA, attend FPGA demo session. You can message our admin, he will tell you the schedule, what is the FPGA demo session schedule. DFT, physical design. Okay. uh, See, choosing the right course, all I will tell is not going through entire thing. You attend 2.5 months of training. That is this August, right? September, mid October also. You can come back and tell that I don't want verification, I want to switch to physical design, or I want to switch to DFT, I want to switch to custom layout. Any domain you can tell, will give you option to switch, no additional cost for that. Only one thing you need to remember is, if you are comfortable with coding thing, you should go for front end domain. If you are not, you don't like, you hate coding, then you should go for some other domain, physical design. If you are okay somewhere in between, okay, you can also think about FPGA domain. Okay, FPGA domain could always be a domain you could always look at as an option. I told you why you should look. Okay, current people are talking about AI, right? With all this, what is the chance? There's always a chance that jobs could get impacted. In that case, where do you have safety? Your own thing, coming out with your own thing. So which is the only thing where you can come out with your own thing in a low cost? FPGA is one domain you can come out with your own products. Is it not doable at all? Is it impossible to do FPGA? Possible, right? So many resources are there. You just go to Google and tell what is the FPGA entire process, tell me from reading spec to everything. It will tell you step by step. It will even give you day by schedule. I want to plan my learning over 2 years, I want to develop my own FPGA board, tell me what to do day by day. It will probably tell you that also. That is how you should be looking at it in the current job market. You should be looking at that perspective. Why you should be looking at, not that you will come out with a product, you will reach a level where you are employable, definitely employable, once you do something like that. Okay. uh, Course flexibility, I told you. What is flexibility? You join any course, will give you option to switch the domain. Preparing for a job. Okay. uh, what is the difficult part of training is, things move quickly. What is that happens is, uh, in BTech, digital design is spread over one semester, Verilog is spread over one semester, network theory is spread over one semester, 5 months, right? Semester is 4.5 to 5 months. You have a lot of time. Here things move quickly and more in depth. Digital design you learn in BTech and what you learn here is very significantly different. Okay, probably what we teach here in your BTech curriculum, you would only learn 30% of it, 30 or 40% maybe, and that is you learn over slowly over one semester time. Here we learn everything over 3 weeks or 4 weeks time. So in that time it quickly moves. So, and here the approach is more assignment oriented. Assignment means what? Everything is problem solving oriented. So what is that you will do? You should be doing, you should be every day, you should be focused on completing the assignments. If you are able to do, good. If you are not able to do, you should take the support from the trainers. Let me again repeat. In our course, since we are doing many things, digital, Verilog, STA, system Verilog, UVM, projects, many things, Python, Linux, 8-9 topics are there, right? Over a period of 8 months. So we are moving from one topic to other topic quickly. So your focus should be on completing the assignments on time. If you are not able to complete, you should get the support. If you don't complete and you don't get support, no one can help. Right? You have to help yourself by completing the things or by getting the support. If you are not able to follow the things, let's say you don't understand Verilog at all, you revise, repeat Verilog course again. You go to system Verilog, let's say you don't understand system Verilog because object oriented programming is little difficult. You again repeat system Verilog. So there won't be any additional cost for repetition. First time repetition, no additional cost will be there. How much time you have to spend in a day? Maybe around 7 hours, including the time you are spending here. Let's say you are here spending 4-5 hours. You go home and spend only another 2 hours. Only 2 hours. No need to spend again full night 11 o'clock also. Because lot of things are done in the classroom only. By going home, you have to revise the things, you have to make notes, those things. Okay. In a 24 hours of the time, you have to find only 7 hours every day for preparation purpose. That if you do consistently, in 7 to 8 months, you will see significant difference in your knowledge, subject expertise. We track the performance of the students. We put them into different brackets. Not to differentiate, idea is to provide the support, required level of support. Someone is not having basics at all. See, there are different people, right, who are already prepared for gate. They are already good with digital electronics. Someone who don't know anything about digital. So there is a different level of support is required. So to differentiate that, we'll do that. So you have to proactively take the support. You should not feel shy. That is where soft skill trainer is coming into picture. Soft skill trainer is to make you come out of that fearing factor, right? See, I'm talking openly, right? I'm not bothering what you're thinking about me, all that. I'm talking, right? So I should not worry also. When I'm teaching here, I should not worry what all the, our soft skill trainer also will do the same thing for you to make you come out of that fear factor. You should openly talk. If you have something to talk to the institute, admin, manager, anyone, you should be confidently going and expressing your things, talking, all that. So that is what we want you to do. Anytime you need support, you should openly come to the admin or come to the trainer and get the required support. Okay. So as part of that, there will be assignments. Your performance will be tracked based on the assignments, attendance, evaluation test. We will make you give the presentation. The soft skill trainer may give you some topic and ask you to present, ask you to talk about that topic. Any random topic, not Verilog, not system Verilog. Any random topic he'll give you 1 day time. He'll ask you to come talk in front of everyone. Okay, over a period of time, 7-8 months time, what happens? You will learn how to talk, how to stop, where to talk, those kind of skills. That is what will be the focus of the soft skill sessions. Okay. For everyone, there will be, and there will be mock interviews. Every topic, there will be mock interviews. Okay. So you have to utilize the things properly. You have to utilize. Means what is meant by utilization? You have to attend mock interview. Many times out of 10 people, only 2-3 people attend mock interview. 7 people don't attend also. When we call also, when our admin also calls, they don't respond. So that kind of things you should come out actually. Okay. You understand, right? Everything is done for a reason. Mock interview is done for a reason. Evaluation test is conducted for a reason. Mock interview is not done to tell that you don't know anything. Not to tell that. It is to understand where are you lacking to provide the suggestions, what to focus, where to improve. So you have to understand that institute never works against you. Institute always works because we want to make sure that you come to the level. Okay. What is the final goal of the training? Student should be enabled to work in the job independently. If you go to any company, let's say you go to HCL, Wipro, anywhere, right? You should be working independently. You should not be dependent on anyone else for small things. It could mean teaching you how to use AI tools. I mean, we will have that part of the training also. How to use AI, right? It's an integral part of our work, right? Our life kind of. So how to use AI in the job and how to bring more efficiency by using those things. That also will be having part of this training. So this is a brief about it. What is the course prerequisites? You should be good with quantitative aptitude, logical reasoning. You know, right? What is logical reasoning, quantitative aptitude? You know, time, distance problems, work problems. I mean, there are some. Those you may say, what is it to do with VLSI? VLSI is about what? Manufacturing of the chip. What is it to do with logical? Your mind should be able to visualize a problem. You know, right? If I give you 2a plus b equal to something, another equation, you should be able to solve what is a, what is b. Something similar here also. Expectation is that given a problem, you should be able to understand what all things inputs I have, how to solve those things. Logical reasoning and quantitative aptitude will give you that basic ability to understand the problem. So it should have, you should have ability to understand the problem. Okay. Next. Yeah, this is about it. Okay. Why you should join our institute is, uh, our courses are more wider actually. Our courses are not focused only for interview preparation. See, there are times where I can give you some 200 question list and I can make you by heart those questions and possibly make you clear the interview also. I can prepare a 300 questions, Verilog 100 questions, system Verilog 100 questions, UVM 100 questions. I can make you clear the interview also, but once you get into the job, you find very difficult. Our courses are generally structured in such a way that it will give you that practical exposure. Everything will be covered with lot of assignments that gives you that required expertise to perform in the job. Okay. And it's a very widely covered topics. What is meant by widely is we don't focus only on Verilog, SV and UVM. We cover protocols, we cover hands-on projects. In summary, there is no limit, there is not much limit for how much you can gain out of our institute. I mean, there are a lot of things where we have expertise. It could be protocols, the different domains of verification. For example, we offer SOC verification, no one else offers. I would say no one in the no institute in the world has that course. I mean, not that it's very complex, not that we are doing some something very thing. It's all done by companies. Let's say Qualcomm will have SOC project, Intel will have SOC project. Institute generally don't set up that. So we have such courses. Point is, if you are capable and you want to learn, we have a lot of things that we can teach you and provide the required expertise. Okay. So that is about it. So we will now stop it and we will go through any question and answers. So those attending online, you can post your questions. Those offline, you can ask the questions. We will try to finish it in another 10-15 minutes.
Sir, this side Rakesh Kumar, Mr. Sir,
Yeah.
what's about placements regarding backlog student? I think 2009 pass out or 13 pass out like this. What is the?
See,
Yes, sir. Tell me.
2013 pass out. What is the only thing I will tell is, there are companies who are hiring the people with education gap. Okay. uh, what is that
Yeah.
I will suggest to you is, you have to choose the domains where the competition is generally less. I told you one domain FPGA. Why I am stressing FPGA so much? My domain is not FPGA. Okay, my domain is verification. Okay, in that case, you should be. My real suggestion is you should be looking at your developing your own product. Something you should conceptualize and should develop, or even if not, should develop so much expertise in FPGA that you can be employable at 2 to 3 years experience level, particularly for you. Since you have a lot of gap, right? You can't apply as a fresher, so you will have to learn any domain. It could be FPGA, layout, DFT, any domain you choose. You develop expertise on par with a 2 to 3 years experience person, then you can get a job.
Sir,
I
is
don't,
it not possible
one
in
second.
ASIC?
I don't suggest you for verification course because you will have to learn programming. After 12, 13 years of gap, learning coding will be little difficult for you.
Sir, I am very much strong in coding, sir. Like in C, C++, Java, Python, data science, like
Okay, then
some courses I
you can
did.
go with this thing. If you are comfortable, you can go with this one only. Yes.
Okay,
That's what.
okay, sir. Thank you, sir.
See, as I said, right, I cannot suggest what is the course right for you, right? Because every individual has their own expertise, their own strength. I know what is my strength. Accordingly, I chose my domain. So what is that? As an institute, I can give you flexibility. You choose verification. You like it, you
Okay, sir.
continue.
Okay.
If you don't like it, switch to other domain. We'll give you that
Uh,
flexibility.
Sir, is there any chances the get for your institute, VLSI Guru?
Yeah, no, yeah, we will definitely support you. I mean, it's not that you have a gap, so I'm not telling we won't support. We will definitely support you. Only thing is you have to gain expertise with a 2 to 3 years experience person, then lot of opportunities will come for you. Because many companies are looking for people with education gap.
Okay, sir. Okay, thank you, sir.
Those attending online, you can post your questions.
Sir, when will this course start? As you have already written.
1 second. I'm taking down all the questions. So you can also post any other questions. Okay, let's go through some of these questions. When the course will start? The course will start from tomorrow onwards. Tomorrow is what? 4th August, right? It will start from 4th August. Initial 2 days will be some basics, but you can also decide to join by 6th August. See, first 2 days is like orientation, some Linux basics, few things they may teach. Even if you miss one or two of those, that's fine, but from 6th August you should be definitely be continuously attending. Average salary of an engineer, it depends. Again, there is no fixed thing. It depends upon which company you start. Typically companies are two types: service companies, product companies. Service company range could be anywhere like 3 lakhs to 6 lakhs or 7 lakhs per annum. I would say 6 lakhs per annum. Product companies could be 5 lakhs to 15 lakhs per annum. It is possible. In most of the cases, you start with services companies. This is how people do. Okay, that is what will be workable for you. You should start with services company, work there for 2 to 3 years. Then you should get into product companies. Is there Perl scripting? Once you learn Python, Perl can be learnt in 1 week. Both are similar. Perl and Python are very similar. Only the syntax is a little different. It's like Perl is driving one bike, Python is another bike. Once you know one bike, you have to just figure out how to use the other bike. Same thing, exactly same thing. Once you know the how to do scripting, Perl is very easy. Learning how to do scripting is the important part. Then why we are talking about Python? Because everywhere Python is being used more, right, these days. Is there SOC verification? Yes. But for you to learn SOC verification, you should be good, comfortable with the basics. That is where we'll be doing the assessment. Our course is not like you just blindly keep attending. After every stage, after phase 1, we'll have an assessment test. Only if you satisfy some minimum criteria, you'll be allowed to go to phase 2. Otherwise, if you give us a commitment that, okay, no problem, I don't bother about placements, you send me to phase 2, I will allow. But if you want the placement support, at every phase, you have to satisfy a minimum criteria. What is minimum criteria? Let's say you should score 60% out of exam. Some criteria will be there. Unless you satisfy, you will not be allowed to go to the next phase. So the SOC verification will come in the phase 4. That is after the mock interviews, everything. By then, when you are comfortable, you will cover SOC verification also. So for example, in this case, we'll cover RISC-V SOC project. We'll do that. But then you have to be at that level to understand this RISC-V SOC. Any other questions in this? Same schedule for weekend batch. Yes. I mean, a weekend batch also takes 8 months to complete. But placement support can start from 6th month. E-learning similar to weekend course? Yes. E-learning will have similar thing as weekend course, because in e-learning also you will have access to all the videos. You will be attending the weekend course, weekend sessions. Even though you are attending weekend course, even during weekdays you can connect with our trainer. Let's say today is Monday, you have a doubt, you don't need to wait till Saturday. Today you can connect with the trainer. We'll create one individual WhatsApp group for you with the trainer added in the group. You can connect with the trainer and get all your doubts clarified. When the course will started, I told you tomorrow it is starting. Do we have mock interview for each session? Is it possible to do mock interview for each session? No. We have a mock interview for each topic. Once digital design is done, mock interview will be there. Once Verilog language is done, mock interview is there. Once Verilog projects are done, mock interview is there. For every topic, there will be a mock interview.
Is it mock interview or mock test?
Both mock test and mock interview, both will be there. There is nothing like mock test. Okay, both test will be there, evaluation test will be there, and one interview also will be there. Interviews make you see. You know what happens is many people, like the way you are talking. 60% of our people cannot talk like that. Those attending online, is it? Am I audible now?
Yes. Yes, you are audible.
So I was telling,
Yes, sir.
mock test and all those is to make you come out of that fear factor. See, the biggest problem we face in the institute is that lack of proactiveness. What is lack of proactiveness? Nobody has taught you that approach, that you have to extract the information from the trainer. You have to take the best possible support from the trainer. You have to go to the trainer, get support from the trainer. Many times people are, okay, I'm not getting, that's okay. That approach will not work for getting a job. So the soft skill and every session is directed in that way, that you should come out of that fear factor. You should start expressing yourself confidently. That is the approach we want to develop, and that is the approach we want. You should not bother what the next person will think about you. That is what is the primary goal. That is what companies also expect. Not that you keep randomly shouting. Ask a questions confidently, put forward your idea confidently. Okay, so to bring out that, we will be conducting mock interviews every month. That soft skill training, everything will be done. Coming to the next question, 24th question. Yes, SOC verification will cover as part of the training. Difference between DFT engineer. What does DFT engineer do? Develops patterns that catch manufacturing defects. Defects that happen at the manufacturing time. These defects are not functional mistakes. See, when you are manufacturing, what may happen? Two metals may get connected. So you are putting metals so close that they may end up getting connected. That is a manufacturing defect. See, what is manufacturing defect? I'll tell you. Electric wires are going right outside. They are put so close that they end up shorting each other. Okay, something like that. Inside the chip, you know how much they are separated by? Nanometers or few micrometers, right? At that level, it is easy for them to get shorted. So the DFT engineer is to catch that kind of bugs. Whereas the verification engineer catches the functional issues. What is meant by functional issues? Some coding has been done wrong. If that mistake is there, it will go into every chip. So that is the difference between them. Is it clear to you?
Yes, sir.
How to decide a person goes to phase 1 to phase 2? Is there a test? Yes. Phase 1, any phase going to the next phase will always have a test. Based on that only, you will be promoted to the next stage. I'm good at Verilog coding. I think we spoke. I was in teaching till now, but now I want to pursue this area. What are your suggestions? It is possible. You should do that. I mean, you can do that. You can think of doing that. Uh, See, if you are good with the things, there is always an opportunity in the market. It's not like there are no jobs. There are jobs. It's that people should be skilled enough for the you should be able to contribute to the company, right? If company is hiring you, they don't want you to sit idle. They want you to be good with the subject, then they will hire you. Even in this case, if you are good with the subject, even if you are 2009 pass out, they will hire you. They don't bother, because companies are not like a government organization where age limit is 30, then only you should not apply. Nothing like that. They work based on the outcome basis. If you are able to perform, even if you are 60-year-old, they'll hire you. BTech mechanical possible to know. Okay. No, it's not possible. You should not even think about this. I mean, I'm telling because you will be wasting your time thinking about this process, and you will be wasting your time and money also. You should not think about VLSI because for mechanical people, companies don't consider either electrical, electronics, computer science. These are open domains. If you are even from IT domain, companies won't consider. Can we catch missed offline sessions in online? Yes, possible. You can, let's say today you went to native, you can attend online. That also you didn't do. You can go through the recorded video. For every session, you will have access to the recorded video. You can revise that. If you miss 3 weeks at a stretch, you repeat the batch, repeat the topic altogether. So institute will give you the flexibility for everything. You have to proactively take the support. This is what you should not think that someone will come to me and ask me what should I do, what support should I provide. Do you think it will happen? No, right? You should be proactively talking to the admin and taking the support. What is the future role of DFT training? Future role is what entire DFT expertise you have to gain. Will you teach protocol from basics? Yes. Okay, we teach few protocols. Like what is the protocols I was talking about? AXI protocol, some protocols, Ethernet protocol. So our goal is not to teach many things, teach few things like SPI, APB, AXI, Ethernet, few things, and teach those from the fundamentals. What is meant by handshaking? What is meant by transaction? What is meant by out of order? There are some technical words will be there. Once you learn those technical words, the same concepts are applicable in other protocols also. So we'll teach from the basics. Next. Uh, Everyone, I sent one form. Please fill this form. Those attending online, please fill this form. Okay. Let's now quickly go through the remaining questions. Another 5-6 questions are there. We should be done with that. Is there any possibility to do FPGA prototyping project in functional verification course? It's not possible because with the current syllabus itself, it's going for 8 to 9 months. If I have to include FPGA prototyping, it goes for another 2 months. So our course structure doesn't allow it. If you want, you can do it as a separate course at a nominal fee. Okay, small additional fee you can do. Okay, like this course teaches the coding from scratch even for them who know very basic coding. Will they be able to learn the course? Yes, it is possible because when I teach Verilog, we'll start with teaching like how to implement a half adder using Verilog, how to implement multiplexer. Then we go on to the gradual complexity, how to implement D flip-flop counter, then state machine. So step by step it will increase. The only difficult part here is that like the way in your BTech curriculum, when you have one semester for entire thing, here you won't have. Like the whole Verilog will start today. By August end, Verilog is completed. That's the only part. That means what? You cannot be, you cannot be relaxing at any time. You should be focused throughout the course. That's the expectation. Otherwise, it's not a very complex thing. The subject is not very complex thing. It's that focus should be there every day. If you feel that 1 month I want to relax, you take off, relax, then come back and again rejoin the course. It should not be like one day you are coming, one day you are not coming, one day you are going out, one day you are coming. Rather than that, you take 1 month off, you finish Verilog, you have good expertise, you take 1 month off, again come, rejoin into System Verilog in the next batch. That is also possible. Institute will give you all the flexibility. Okay. So again, in what context I was telling, we teach everything from the basics. If you put the right effort, you will be able to learn the things properly. Is digital design would be the first syllabus to be covered? Yes, digital design is the first thing we start with. Are you teaching digital, analog and digital design concepts? Analog concepts, very basics, only 1 or 2 sessions will be covered. Not, I won't even say analog. Analog means what? You have to start teaching op amp, diff amp, all those things, right? PLL, everything. That we cannot cover. Okay. We'll teach the very basics of CMOS, that's all. Is it possible? How is it possible? How is it means what? Companies are okay. How can I question company? Why are you hiring CSC people? CSC people come with some expertise, right? They all at times they do some Verilog coding courses also. In Verilog, in their syllabus, some coding syllabus will be there, right? So their companies are okay. Companies are okay as long as they come with the right skill set. They will hire. Why they don't hire mechanical people? Mechanical people learn something else completely. Don't do any programming also. They don't do any electronics also. At least computer science people will do what? Programming, right? Something is relevant, right? So then that's why they hire. So that mostly answers questions, I guess. And last question is what? As we take RTL design and verification course, am I eligible for RTL design engineer and verification engineer role? Yes, it is possible. You can learn. You can also get into design role because you will be learning Verilog coding concepts, how to implement a design using Verilog. Okay. And parallelly, you will also learn verification also. You can fit into both the roles. It is possible. Okay. Yeah. So this is about the session and the question and answers. Those in offline, you have any questions? I'll be here after the session for another 10 minutes. If you have a question, you can always come to me. Okay. So let's end the session here. The course is starting tomorrow. Actually, yesterday was the planned demo session, right? We delayed because I had some company training, so I could not postpone it. So we had to shift this. Okay. Tomorrow onwards, session will start. Our trainer will tomorrow give you the complete schedule. Roughly, I've given you the schedule, right? Initial 3-4 weeks will be digital, very large system, very large. Same schedule. In that also, they will give you the further breakup. Okay. So let's end the session here. Those attending online will end the sessions. Thank you.
I have a question. Like, I would like to come down and talk to you. Will you available today? Sometime in the institute, probably. Like, I'm coming from electronics.
Not me. If I'm available, you can meet me. Otherwise, our manager Vaibhav will be there. You can also meet him.
I mean, I would like to talk with respect to the technical point of view.
That's what.
If
No,
you
no. He's
remember,
also technical person. Even though he's a manager, he knows the entire aspects of VLSI domain. You can talk to him. If you are dependent on me, then it will be problem, right? Because I may or may not be available, but he is available. So you can talk to him. If you still have some doubts that you want to clarify, you can talk to me.
okay. May I know the specific timing? Like, when can I come down and talk?
You can come before 5:30. That will be better.
Before
5:30,
5:30.
6. Before 6, you can come. He will be available.
The location, what is mentioned in the Google map, it is the
Yeah,
institute, right?
exactly. Same location.
Okay. Thank you very much.
Okay, sure. Thank you. Yeah. Any others? Any questions? Those attending online? Okay, fine. Thank you.